started with these questions. They are on quadrilaterals because tonight, like I said, we're going to spend some time just revising the whole chunk of geometry that we've done, midpoint theorem and quadrilaterals. So I've got 5 questions up on the board, and you have to say if they are true or false. I'm going to leave you for about 3 minutes to do them on your own, so don't post anything in the chat. When you are done with the questions, you can put a thumbs up in the chat so that I know that you are done. Okay, off you go, give them a try. Remember, if you are saying false, make sure you know why you are saying it's false. Okay, so Lydia and Asanda are done. Let's give everyone else a chance so long to think. Okay, Verona. Oh, hi, Verona. Verona's back today as well. And Leah's also here. Some familiar faces, some regulars. Right. Okay, looks like most of you are done now. So let's start answering the question. So feel free to put your answer in the chat. A rhombus is a quadrilateral with diagonals that bisect at right angles to each other. Is that true or false? So the diagonals of a rhombus bisect at right angles to each other. People are saying false, false. Okay, let's remind ourselves of the properties of a rhombus. It's got all the sides equal, and then indeed its diagonals do bisect at right angles. So it is actually true. Okay, yes, Leah, you're right, it's true. So those of you who said false, yeah, it's true. It's important that you know these properties for your paper 2 backwards and forwards, okay? Definitely bisects at right angles, a rhombus. Okay, let's go on to the next one. A rectangle is a quadrilateral with equal diagonals. Put your answer in the chat. Don't guess, eh? Look it up. You don't have to try and remember it if you can't. Look it up. Look at your textbook. Ah, better. Yes, this is also true. The diagonals are equal. Okay, now let's see the next one. If one pair of opposite sides of a quadrilateral is equal, the quadrilateral is a parallelogram. One pair of opposite sides equal. Is this true or is this false? Nelly says false. Angela says false. I agree. It is definitely false because we need one pair of opposite sides to be parallel and equal, or we need both pairs of opposite sides to be equal. Good. Okay, if one pair, number 4, if one pair of opposite sides of a quadrilateral is parallel and equal, the diagonals are equal. Is that true or false? Rona says true. Lydia says true. Tando also agrees true. False. Some people are not putting their answer in, not sure. Okay, I would definitely say that this one is false because it says if one pair of opposite sides of a quadrilateral is parallel and equal, the diagonals are equal. Yes, that works for a rectangle, but it doesn't work just for a normal parallelogram. So if you have the only quadrilateral, by the way, the only one with equal diagonals is a rectangle. So if you go to your textbook or if you go to your notes or something, you should have something like this where we show that the diagonals are equal and one pair of opposite sides are parallel and equal because it's a rectangle is also a parallelogram. But if you go to a normal parallelogram and you have one pair of opposite sides parallel and equal, we know that the properties of a parallelogram is that the diagonals are not equal in length and that they just bisect. Okay, so this statement is only true in the case of a rectangle, but it's not true for all other parallelograms, okay, and quadrilaterals. So I would go with false here. Okay, and then the last one, number 5, if all sides of a quadrilateral are equal, then all angles are equal. Also think carefully about this one. If all sides of a quadrilateral are equal, then all the angles are equal. Is this true or is this false? Harti says only for squares, so false. Asanda says false. And that's right. Well done, Hartis and Asanda. This is indeed false because it only works for a square. It doesn't work for the other, for rhombus. So the two quadrilaterals with all sides equal is a rhombus. Let's draw them here. And we know that the opposite angles of a rhombus are equal, but not all the angles are equal. And if you go to a square, yes, indeed, all the sides are equal and the angles are 90 degrees. So it's true, but it's not true for everyone, for rhombus as well. Why is number 3 false? One pair of opposite sides of a quadrilateral is equal. The quadrilateral is a parallelogram. It can't just be one pair of opposite sides equal. It has to be one pair of opposite sides parallel and equal, or both pairs of opposite sides equal for it to be a parallelogram. Okie dokes. Good. That was a nice warm-up. Get you thinking. You might see some of these types of questions if your teacher put them into the exam. Let's do this next one where we have to prove that something is a parallelogram. Okay, so these I got from past papers and stuff. So let's have a look. Okay, I'm going to give you a minute or two to read the question. And as always, when you're done reading, put your emoji in the chat that shows your reading phase. And then also start thinking. You might want to quickly draw it there where you are on your page. It really makes it so much easier if you have a sketch to work on and from, where you can mark stuff, use colors, etc. So maybe you want to do that quickly as well. And then it's time to start strategizing. How are we going to answer these questions? Okay, so when you're done reading and drawing and strategizing, then you can put your glasses face in the chat. Strategize then as well, guys. Harties and Canva. Start thinking of how you're going to prove this and how you're going to do it. Quickly jot it down where you are. And remember, you are most welcome to take screenshots. Just putting the eyes. Okay. So does anyone have any ideas how we are going to prove that triangle PQO is congruent to triangle TRO? Any ideas how we're going to do that? Raise your hand if you want to share your idea with us. Or you can put it in the chat, but it's so much nicer when you guys speak to us. So you can start by just maybe highlighting those triangles that need to be proven. It's that one and this one. So far we've got two sides. So we can either try and get a third side, or maybe an angle. How would you do it? Okay, so Eunice is saying PQ is equal to RT, and that is common. And that is given. Okay. Guys, if you don't feel like typing so much, just put your hand up and unmute yourself and tell us how you would do it. Remember, you've got parallel lines as well. So there's lots of information to work with here. Would O be the midpoint of PT and QR? No, we don't. It's not given, and it is not. We can't say, we don't have any other geometry that we can use to actually say that O is the midpoint. PO is equal to TO given, yeah. P is equal to T given. Artis, I think you must just be careful there. P, is it an angle? Do you mean a side? So sides go from one point to the other. So PT would be a side. And if you meant to refer to an angle, then you can go QPO, for instance. That would be an angle. Lydia is saying that angle P is equal to angle T. So you can just write angle so that I know you mean an angle. But yeah, that's right. So here we go. Angle QPO is equal to angle RTO because they are alternate. And PO is equal to TO indeed, yeah. Okay, and I think we've got enough to put our congruency proof together. So we're going to write in a triangle PQO and triangle TRO we've got PQ equal to RT, that's given, like you guys said. And then PO equal to OT, that's also given. And then our third statement is going to be that QPO is equal to RTO. Oops, I put my hat on the wrong letter. And that's alt angles. P is parallel to RT. So which case of congruency do we have here? Put it in the chat. Lydia, QR would, if it's common, put in the chat. What case of congruency have we got here? Side, angle, side. Yeah, okay. So now we can say PQO is congruent to triangle TRO because of side, angle, side. Good stuff. Now we have to prove for 2 marks. Okay, so look at your mark allocation and make sure that you don't spend too much time on it if it's only 2 marks. Yes, Asanda. Yes,
Hi,
Asanda.
ma'am.
Hello.
When do we tell if an angle is a side angle side or side angle?
So when you have side angle side, it's 2 sides and the angle between them. So it's where those 2 sides meet, like we have in this case. Do you see where PQ and OP meet at point P? That angle is the 2 sides and the angle between them. So, and if it was angle side, then you would have, say, for instance, like this, and you'll have that angle, the side, and the other angle. It would look like this.
Yes, ma'am.
Okay.
If we have side, there is no angle.
3 sides, side, there's no angle, no.
Okay, thank you, ma'am.
Okay. Right, so how are we going to prove that PRTQ is a parallelogram? Put your hand up if you want to answer. It's only 2 marks, so it's already there. You don't have to do any extra work. Anyone want to venture how? Let's highlight our quadrilateral. So it's PR, TQ. Yes, Nkateko. You can unmute.
Ma'am, I said that QS is parallel to, not QS, ma'am, QP is parallel to PT, which makes it a parallelogram.
Yes, because PS is parallel to RT, and RT is equal to PQ. So here we have a situation where we have one pair of opposite sides parallel and equal. So that makes it a parallelogram.
Yes.
Okay, so I'm going to write everything. You wouldn't need to write so much, but I'm doing it just so that you've got a complete solution. If you need it, that's given. And PQ equal to RT is also given. And the thing that you have to write is that PRTQ is a palm or a parallelogram. You can abbreviate it like that. One pair of opposite sides parallel and equal. Parallel and equal. Remember, there are those 5 ways in which you prove a parallelogram. This is one way. The other way is both pair of opposite sides parallel, both pair of opposite sides equal. The opposite angles can be equal. And yeah, so, and this one as well. Okay. Right. You can go back to your notes from when we did quadrilaterals last week and the week before that, and it's all there. You can also watch the recording again if you can't remember. Right, let's look at some midpoint theorem problems. And the other one is also for the parallelogram, that the diagonals bisect each other. That's also another way to prove. Okay, so we are given AD is equal to 5 centimeters over here. Remember to transfer anything that's written here to your sketch. MC is equal to 6 centimeters. Calculate with reasons the length of BM. We're going to start there and work our way. Right, does anyone know what BM is equal to? Yes. Can anyone explain why it's 5 centimeters? Anyone want to raise their hand? Tell us why you think it's 5 centimeters. Okay, so let's start with what's given. What's given is the fact that, okay, so these lines are parallel and C is a midpoint. So that would make M a midpoint as well. And I'm going to make 3 just for now. But also, this is a midpoint, P is a midpoint. And DE is parallel to MC. So if that's 5, then this must also be 5. And then this is 5 as well. So you basically do the midpoint first in triangle BED, and then in triangle AMC, or the other way around. Didn't matter where you started, it would have brought you to the same point. Okay, now we have to write down that whole answer with all its reasons. So let's start with the fact that BC is equal to CE, and that is given. Sorry. And then MC is parallel to DE. That's also given. Thanks, Verona. Thanks, guys. I don't know what to do with all these blessings I'm receiving. Thank you. And then we can say that, therefore, BM is equal to MD, and that is line from midpoint parallel to second side. Please don't tell me to wear a mask again, Arties. I might just cry. Okay, line from midpoint parallel to second, oh, not time, but side. And that's just because, also, by the way, you can use converse midpoint theorem. I've actually confirmed that the other day with someone. Converse midpoint theorem is perfectly fine. Okay, so we've got that, and then we go to the other triangle. We can say AP is equal to PC, that's given, and BM is, let's fix this quickly, DE, I don't know why I wrote DM. DE is parallel to MC, and that is given. Therefore, AD is going to be equal to DM, is going to be equal to 5 centimeters. Also, converse midpoint theorem, or line from midpoint parallel to second side. Okay, so that's 1.1. Let's go to 1.2. So 1.2 is DP. DP, I think, is fairly easy. That we can just say is 3. Because MC is 6, so DP must be 3. And we can also just use line from midpoint parallel second side or converse midpoint theorem. I'm writing both just for those of you who learned the different ones, so that you also get a chance. And then the length of DE. So if this is 3, then we need to figure out, okay, so that's 3. MC is 6, so the whole of DE is going to be 12, and that's going to be 9. Yeah, so Harties, don't forget to add the 3 centimeters, so that's going to be 12. 12 centimeters, and same reason, converse midpoint theorem. Okay, give me a thumbs up in the chat if, no problem, if you are happy with that. Yep, how's everyone doing? Let us know. Yes, Bom, you can unmute.
Hello, ma'am.
Hi there.
Ma'am, why is DE 12 centimeters, ma'am?
Okay, so if you look in this triangle, I'm going to highlight it in red. This one here. And in this side, we said was 6. So DE must be twice MC because of the midpoint theorem. So that's why DE. Yeah.
Okay, thank you, ma'am.
Okay. Use your colors. Yes, Asanda's next.
Hi, ma'am.
Hi there.
Ngiyancola ngithetha ngomlungu nina.
When do we say midpoint? When do we say converse midpoint?
You say converse when you have a midpoint and a parallel side. You use midpoint if you have two midpoints. So the midpoint on the one side and the midpoint on the other side. That's when you start, then you use midpoint. If there's a parallel line and one midpoint given, then it's converse midpoint theorem.
Thank you, ma'am.
Okay, no problem. Okay. I think we've got time for one more question quickly. Let's do this one. M and T are the midpoints of AB, BC, and AC of triangle ABC. Okay, so in this case, do you guys see we are only given midpoints? So we are going to go straight to midpoint theorem. So here we won't need to use converse midpoint theorem. Here we're going to use midpoints only. Okay, and because we have these midpoints, we can say MT is parallel to BT. Now, the question's asking for the interior angles of triangle MNT. So, okay. This is a nice question. I think we should all be able to do it. It's definitely not as difficult as it looks. Okay. So let's give it a go. Let's start with angle C. If you don't know where to start, always start with what is given and try and find another angle that's equal to the one that is given. Or use your angles that are given to calculate other angles. So we can calculate angle C over here. Pop it in the chat if you know what angle C is going to be. Warona says 40. I agree with you, Warona. That's 40. Okay, so for a question like this, we are now just going on a fact-finding mission, all right? So we can also then say if this is 80, then this angle must be 80 degrees. And that's because of corresponding angles. And that will mean that this one's 40. Okay, we can also say that this side is 3 because it's half of BC. And this side will be 1. And this side will be 2. There we go. Now, okay. Anyone else have any other ideas?
Can't we say the
Sorry, Miss Nelly, what did you say?
I was thinking like the line below M, you know that above that line, M is equal to 80 degrees. I think below it will be 60 degrees. It won't be 60 degrees.
60 degrees? No, I don't think so.
Oh, where are the parallel lines? Oh.
Yeah. Oh, and wait, we've got parallel lines here as well. These ones. And then we have another set going this way. Like that. It's like a big puzzle. So we must look for something that is, yeah, because then AB is parallel. Oh, here we go. AB is parallel to AC. So we can say that the AT here is alternate. So this AT is alternate with that AT because of the parallel lines, the pink ones, the pink parallel lines. Okay, and yeah, it's just going to be a matter of figuring out all these angles using your parallel sides, your parallel lines. Okay, so then we can go straight line. I'm just filling things in as I see it. So 40 plus 80 is 120. So this is 60. And then can we do some more alternate anyway? Yep, this is 60 because of alternate. Again, AC is parallel to MN. And let's see what else. We just need one more. Oh, we can then do this last one using interior angles of a triangle. So 80 plus 60 is 140. So that will be 40. Okay. Right, guys, you're welcome to take a screenshot and do that one as a sort of puzzle that you can solve for yourself, because it's you're looking at the triangle in 3 different ways with 3 sets of parallel lines. So it might be a nice little practice for you for your exams.